Hi, this is a video on how to simplify complex fractions that do not contain negative exponents. I have a separate video on how to deal with negative exponents. So I have this very complex fraction that I'm looking at, and the first thing I want to do just to get going is recolor this so that I can tell which fractions are which and kind of read this as an overall fraction. So I'm going to rewrite each term in its own, each rational expression in its own color. So this is 9 over x plus 4. That is its own fraction. And then plus, and this is 6 over x plus 5. And that's over, different color, that's over 5x plus 23, x squared plus 9x plus 20. So that you can see that this plus sign is a part of the original fraction, but nothing to do with the individual rational expressions. And this is the big divider that tells me this whole upper part, the 9 and the 6 over their denominators, is the numerator of this large fraction, and this 5x plus 23 over its denominator is the entire denominator of the fraction. So when I'm dealing with complex fractions, I want a jumping off point, and that is usually just to simplify any denominators that aren't already simplified. So I'm going to simplify my blue denominator. I wrote that wrong. That's missing. There you go, 23. That makes more sense. Nope, sorry, it's 20. 20. There we go. Okay, so I'm looking for two numbers that will multiply to give me 20 and add to give me a 9. Alright, so that would be 5 and 4. So that means that this denominator, the blue one, would factor into the pink denominator and the yellow denominator. And that tells me that I have a unique way of simplifying this fraction, and that is to rewrite the numerator as a single fraction containing the denominator. So I'm going to simplify the pink and yellow fractions. I'm going to multiply the yellow denominator into the pink fraction, and I'm going to multiply the pink denominator into the yellow fraction, giving me a single numerator over a single denominator, which will happen to match this blue denominator. Alright, so let's go ahead and do that. I'm going to have pink, I think that's the same color, 9 times x plus 5 for the yellow denominator over x plus 4 times x plus 5 plus, we write that in white so we can keep track of what we're doing, and then in yellow I have 6 and then x plus 4 for the pink denominator divided by x plus 5 times x plus 4. Alright, switch back to white, and then blue for the original big fraction. And that is 5x plus 23, all divided by x squared. Oh, actually, I'll write it in the factored form now so it matches. That was x plus 4 over x plus 5. And now all of the denominators in this fraction match. Oops, missed a yellow. Closing parenthesis, there we go. Alright, well that equals, I'm going to simplify that numerator, so I'm going to distribute the 6, and I'm going to distribute, that's the wrong color, distribute the 9. So that will give me 9x plus 45 plus yellow 6x plus 24. If you have this many colors at home, it really does help to write them in this many shades. That gives us one new fraction, so I'm going to choose a new color, green, to signify that I've turned this into a single fraction with the same denominator is the blue denominator below. This is still the big main fraction bar. Make it nice and dark. And I still have that blue denominator that I haven't done anything to except factor. 5x plus 23 all over x plus 5, x plus 4. Okay, so now I need to combine like terms. I've got a 9x and a 6x, that gives me a 15. And I've got a 45x and a 24, that will give me a 69. So down here I'm going to rewrite that numerator. I'm going to rewrite it in green because I have a brand new, completely brand new fraction. The pink and green have mixed together, or sorry, the pink and yellow have mixed together. So I said that had given me 15x plus 69 all over x plus 5 times x plus 4. And I still have the big main fraction bar in white and the same blue denominator that's been following us around the whole time, and that is 5x plus 23 all over x plus 5, x plus 4. And some of you may have heard this keep, change, flip from algebra. Keep the numerator, change division to multiplication, and then flip the denominator. So turn it over, use the reciprocal. Keep, change, flip. And that is how we simplify a complex fraction. So let's do that. So I keep the numerator, the green part, 15x plus 69 over x plus 5, x plus 4. I change the division sign now because multiplication, so this white is this, became multiplication, and I flip the denominator, the blue part. So now I have x plus 5 over, times x plus 4, and I do see that mistake there now. Fix that, I got carried away with the 5s. That should have been a 4, close parenthesis, and go back and write the rest of the blue fraction. 5x plus 23. You may be wondering, since I have the power to edit these, why I don't take out all my mistakes, and that's because I don't want anyone to believe that math is a perfect process. We all make little mistakes along the way. It's just really important that we backtrack and make sure we're on the right page as we're moving forward. Okay, so now I have this new expression to work with, and I can see that this denominator, oops, wrong color, and this numerator will cancel, leaving me with just this numerator and this denominator. So I'll move to the next slide and write that. Actually, I want to take that away before I move over there. Okay. So let me choose a brand new color because, oh, what have I not used yet? I have not used gray for a reason. That's a little bit hard to read. So let me change that to peach. So that gave me, let's see, that gave me 15x plus 69 over 5x plus 23. I know that 15 and 5 are related by a 3, so I'm just going to see if I can find that 3 in 69. So I'm going to come over here. I'm going to divide this. It's too high. 69 divided by 3. I'm just going to see what happens and see if that gives me a 23. So I go to that twice. That gives me a 6, and I bring that down, and then I get this 9, and that gives me a 3. Oh, and it is 23. Okay. So that's a 3 times 5x plus 23, if I factor that 3 out, over 5x plus 23. And those two things will cancel. And look at that. The answer to all of that madness on the first slide is just 3. Let's go back and walk through that one more time. going to get a nice bright highlighter color to work through this. Smaller size. Let's do a nice purple color. And let's see, this was the original problem right here. We rewrote it using our colors. That's the only thing that happened between those two steps. We factored the blue denominator, and when we did, we found these 5 and 4 were related to the pink and the yellow up here. And so we moved forward with the pink and yellow. We turned these into one fraction with the same denominator by building up the numerator here. We carried the 9 and the 6 in to the binomials to create this numerator right here. We simplified like terms, and that gave us this new fraction right here. And then we did our keep, change, flip to get to this step right here. Keep the numerator, change division to multiplication, and then flip over the denominator. On the next page, we took that simplified denominator because this and this canceled, leaving us only with this green part and this blue part. Sorry, this is getting really messy. And that was right here. And then since we knew this 15 and this 5 were related by a 3, we went ahead and checked to see if this 69 and this 23 were also related by a 3. And we found that to be true in this scratch work right here. So that gave us 3 times 5x plus 23 over 5x plus 23, and those two things canceled out, leaving us with just a pretty 3 as our answer. So the solution for this guy was just 3. Alright, I hope that helps with simplifying these complex fractions, and I will see you in the classroom.